All right. Good morning, everybody. Had a fun weekend? How many inches of snow did you get? I asked because last time we got a snowstorm. I live in Arlington. We got like maybe 6, 7 inches. And then on my way home from here, I went through neighboring Lexington, and it was like a foot there. And I live like a quarter of a mile away from that town. So apparently there was a cloud over Lexington that didn't make it to Arlington. So this time it seems to be more uniform everywhere. Anyway, are there any questions about the assignment that I can answer? Maybe that's online. Have a question? All right. Yeah. So before we start, it's been about 3 odd weeks now. I just want to know how is the setting and everything going on for everybody? Are you able to reasonably get everything that you're supposed to get in the course? The lectures, 48-hour lecture recordings, the lecture delivery here. This is a question for both in class and those of you who are at home. Is there anything I can do to make it better? I know this is far from being ideal, but when life gives you COVID, you make lemonade. So if there's anything I can do to make the classroom experience or the overall experience better for you, I'm all ears. I'm very receptive to any suggestions anybody might have as to how we can do this better. Okay. For those of you who are viewing looking at the lecture recordings, how muffled do I sound? Can you make out what I'm saying in the recordings when you do listen to it? Okay, because that was one of the concerns I had from last semester. I started last semester wearing a filter inside my mask just to be sure, and then I discovered that in the recordings, it's basically, if the professor was being mocked as they were lecturing, what would they sound like? And that's what I sounded like. So I took that out, and that made things better. But I just want to make sure that it's reasonably clear in the recordings. Okay, good. Thank you, Nicole. All right. So as is the plan that I said last time, all this week and perhaps next week, I'm going to spend a few minutes of every lecture kind of going through one of the problems from lecture 8. So after that problem, we will start with lecture 9 today, and then same on Wednesday. We'll tackle a problem, or at least talk about it, if not solve it completely, and then move on to lecture 10, and so on and so forth. Okay? So hopefully you have had a chance to at least look at these problems. If not, problem 1 is about making your own data definition and writing a few methods. Problems 2, 3, and 4 are related. Well, problem 2 has 3 variants, and so 2, 3, and 4. They are variants of each other. It's different versions of the same problem. Okay. So let's tackle problem 1. It's the data definition is fairly simple. So even if you haven't looked at it, you can kind of follow along as we go about today. So problem 1. Relating it to the assignment, the kind of problems that you're solving in this current assignment, problem 1 probably is the most similar in that you have to come up with the data definition, and then you have to write some methods that actually are quite similar to the methods that you have written, that we saw in earlier lectures. Okay? So I have it projected on the screen. Those of you who are on your laptops can just read off the lecture notes as I'm doing this. Problem 1 is, suppose you're working on a research paper and you've gathered a set of documents together for your bibliography. The 2 kinds of documents, books and Wikipedia articles, and then each one of those has an author, title, and a bibliography of documents. Additionally, books have publishers and wiki articles have URLs. Okay? And so what follows are 3 methods that you have to write on this bibliography. Okay, so let's talk about the data definition first. So you have gathered a set of documents together for your bibliography, books and Wikipedia articles. So that's a good starting point. We can have books and Wikipedia articles are both kinds of documents. So that's a union type that we can have. And so we come up with an I document. And then we have a book and a Wikipedia article. Okay, and so we have, that's our interface, and then these are our classes that implement that interface. Okay, if you look at the problem more, it says you've gathered a set of documents together for your bibliography. So how should we represent a bibliography now? How do we represent a bibliography? Yes? It would simply be a list of documents. Okay, and so we'll stick with the naming convention inside in all the lecture notes. So we have an ILO document. And so we have an empty low document and a cons low document. Okay, and so the cons low document has an I document. And a rest that is an I low document. Okay, and so that right there is, oops, that right there is our bibliography. Okay, now let's complete the data definition here for a document. So it says every document has an author, a title, and a bibliography of documents. Okay, so what type should we use for each one? Author. We could use an author class, or for now we can just stick a name in there. It does say format the entry. So looking ahead for the methods, one of the methods says last name, first name, and so on. So there are more than one pieces of data for an author that we want to represent. And so we can go back to using the author class. So I'm going to make space for it here. So every document has a title. Wait, what does it have? Author, title, and bibliography. Okay, so author. Author, we'll come up with an author for everyone. Title. Title can be a. Title can be a. How do we represent it? That's not too hard. String. String. Good. And a bibliography of documents. So this is our representation for a bibliography of documents. And so we can say bib ILO document. And then, in addition, books have publishers. Okay? And so publishers is like Addison Wesley, for example, or McGraw-Hill. So how should we represent a publisher? We could represent it as a string, unless we know that the publisher itself has several pieces of information, in which case we write a class for it. Okay. For now, let's put a string there, and then if we discover that when we are writing the methods we need more pieces of data, we can change that. So book has a publisher. And your wiki articles have URLs. So URL is a string. Okay? And so that becomes the data definition. Okay? Questions so far? Simple enough? Now, one interesting issue is when you write those classes, you write constructors for them, right? And so when you create a book, you specify the author, that's fine. You specify the string, that's okay too. You specify a publisher, that's okay too. But the other field is an entire list, a bibliography, right? And so we could create an entire bibliography for a book. And then once we have it, then we just provide it to the constructor like we provide all the other fields. Okay? Alternatively, we can write a method in the book class, and probably also in the Wikipedia article, that is going to add a document to its bibliography and then return us the resulting publication, the resulting document. Okay? So you can do it either way. If you do it the second way, what is the advantage? What are the implications, I should say? So the second way is that you give the ability to add a document one at a time to a given document in the bibliography of a given document. What are the implications if we design it that way? What are the consequences? Try to imagine it. What would be easy, difficult? So if we didn't have, the first advantage of doing that would be we don't have to construct an entire list of documents in order to provide it, okay? In order to even create a book. But there's also a more practical problem. What if you have two books, okay? And it is often the case that books or articles cite each other. And so book A cites book B, and book B cites book A. Okay? You might wonder, how is that going to happen if they're published at different times? Or what if they're published in the same year? And so the earlier book might cite the book coming later saying, well, to be printed or something like that. So it's possible it happens, right? And so if that is the case, we have a bigger problem because you have the chicken and egg issue here. If we have to create those two books, in order to create the book, we're going to have to create the bibliography first. And in order to create the bibliography, we need to add the second book to it that we haven't created yet. Okay? So this is actually a complicated problem. And in about a week, we will see sort of a better way to solve this. Okay? But we can begin to look at a possible solution by saying, okay, when I create a book, I'm not going to give it the entire bibliography. Instead, I'm going to write a method in that book class that is going to take in a document and then return a version of this book that has that document in its bibliography. Does that make sense? Kind of like the discount book, where it takes in a discount price and then it returns a version of this book that is at that discounted price. So we can write something similar here. Okay? If we make a decision to not supply the entire bibliography when we create the book, that means that when we write the constructor for the book class, we don't have to take in an I document, an ILO document as one of the arguments. Normally, we write constructors that take as many parameters as there are fields. And this is usually the most straightforward constructor, where you take, if your class has 4 fields, you write a constructor that takes 4 parameters, and then you just assign them. Okay? But in some cases, like in here, if this is the design we are thinking about, then every book or every Wikipedia article will start with essentially an empty bibliography. And so since we know that the bibliography is going to be empty, we don't need to take in an empty list as a parameter. We can directly create it inside the constructor. Okay? And so we can write a constructor here that takes not 4, but 3 arguments, 3 parameters. An author, a title, and a publisher. And then inside the constructor, we can say this.author equals author, this.title equals title, this.publisher equals publisher. But then we say this.bib is new empty low document. Instead of taking it as a parameter, we can just assign it right there. Okay? And this is a slightly different constructor that we have seen, where the constructor has fewer parameters than there are fields. And this is not wrong, because remember that the job of the constructor is to give initial values to all its fields. One way to get the initial values for all its fields is the constructor taking them in as parameters. But it doesn't have to be the only way. If you know what the default value should be if you know what the value should be of a field, if you directly know it, then there's no need to pass it to the constructor. Like in this case, I know that the bibliography starts out as being empty. And so if it is empty, then we can just write in the constructor this.bib equals new empty low document. Does that make sense? Any questions? So remember, the job of the constructor is to give values to all its fields. There can be many different ways in which you get those values that you assign to the fields. Okay? All right, so moving on to, let's talk briefly about the methods. We want to produce a bibliography containing just the authors and the titles of the books you found, either directly or transitively through the bibliographies of other documents. Okay? Format the entries as last name, comma, first name, period, and title in double quotes. So given this information, can we design a method signature for this? It's a method that we write in the bibliography that produces a bibliography that contains just the authors and the titles of the books you found. And it's giving you a format. So where should this method go, first of all? This method that we are trying to design, where should it be? We have 2 interfaces and 4 classes here. Where do you think the first method should be? Where do you think I should put this method? Which interface, which class? Well, I want to produce a bibliography containing just the authors and the titles of the books we found, either directly or transitively through the bibliographies of other documents. So since we want to produce a bibliography containing the authors and the titles of the books we've found, either directly, so directly means it's there in the bibliography, or transitively, which means it's there in the document, in the bibliographies of the documents that are in this bibliography. Okay, so you have a bibliography, some books, some articles. Each one of them have their own bibliography. And so we are supposed to take all of this and produce a bibliography that just contains authors and titles of the books. Okay? And so it's a method that belongs in a bibliography. That's right. That should be right here. So let's say we say bib books is the method here. Okay, it's the bibliography. It already knows everything to produce such a bibliography, so it doesn't take any arguments. Now it should produce a bibliography that contains the titles and the authors of the books. Okay, but the bullet also says format the title and the author in the given format. So what exactly should this method return? Yes? It should return a list of strings. Each book will be a string according to that format, and the bullet is saying return me a bibliography. Okay? And so it will be a list of string. So then we'll use the ILO string designed from, I think, the assignment. And design it like this. All right? The question is, how do we actually implement this? So imagine you have a bibliography. Number one, you're supposed to ignore all the Wikipedia articles. It's only the books. And once you do get a book, you're supposed to format that book in a specific string. Okay? The string contains the title and the author of the book. So how should we go about designing this? Victoria, what did you mean I document for the previous question? Where should this book be? Where should the bib books method be, or is that in response to something I said recently? Well, where should it be? So once we do have a book, we are supposed to format it as a string. So where should that method be? In order to get that string, we need the title of the book and we need the author of the book. And then we can put them together in a string. So such a method likely belong to the I document. Okay? And so we need it ideally over here. That will just cite the book. And it will return us a string. We want it to return a string of that type for the book, and we want to ignore the Wikipedia articles. So if we put that method here, then we would need to know that the object we have is of type book. so that we can actually call it on here. Okay? Or we can put this method here in the interface. And that way, we can just call it on an iDocument, and dynamic dispatch will take it to the book or the Wikipedia article. Okay? And so when we implement this method here in the book, we know how to implement it. We take the author, we take the title, and then we create a string based on that. Yes?
Are we supposed to cite the bibliography of the
Are we supposed to what?
cite the books inside the bibliography of the
Yes, you are. And so let's look at the problem. Since we know wiki articles are not necessarily authoritative sources, you want to produce a bibliography containing just the authors and titles of the books you have found, either directly or transitively through the bibliographies of other documents. So it says other documents, and so you can assume that to mean a book might be cited by a Wikipedia article. So we don't want the Wikipedia article to show up in our resulting bibliography, but we do want the books cited by that Wikipedia article in there. Okay? And so if we write a cite method here, then in the book class, we can just create a string and return it. The Wikipedia article, we need to implement this method. We can do so by just returning an empty string. You can return an empty string by just doing that. So that's one way to approach this. Okay, Luke asks, what is a good way to determine if the helper should be in the interface or just that class itself? I always have trouble determining that design choice. That's a good question. So perhaps when we think of the method, we are thinking, okay, we have to do this for the book class, so let's start by putting it in the book class. Okay, no harm starting there. But then when we think about it, if you have a method that is specifically in the book class, then in order to call that method, we need to have an object of type book. Okay? So the question is, what are the different situations in which we might call this cite method? We're going to have to call the cite method when we have a document in the list and we wish to produce a citation for it. Okay? Now, the things in the list of documents are actually in the cons law. There is an iDocument there. It's not a book. And so if we think about where are we going to call this method from, well, we are likely going to call that method from that cons law when we chance upon a book, and then we wish to convert it to a string. So we have an iDocument in that one. In order to call the cite method that is specifically in the book, we would have to ask the question, is this iDocument a book? And now we come to the question that we should avoid. We should refrain from trying to write code that explicitly asks the question, hey, what kind of a document are you? And so how do we avoid that question? We avoid that question by letting dynamic dispatch figure out whether it's a book or not. And therefore, in order to leverage that dynamic dispatch, we put this method in the interface so that now we can call it on an iDocument, and then dynamic dispatch will go correctly to the book class if the iDocument in question is in fact a book. Okay? So see how that thought process kind of led you to the answer? You can start by putting it where you think it intuitively should belong, but then try to think of the examples. Where are you going to call this method from? Whichever place you're going to call this method from, place or places, what kinds of objects do you have? What do you know about them? How easy is it going to be to actually call this method? And that will lead you to the correct answer. If, for example, you only had in your design, there was a place that specifically just had books, then you wouldn't have a problem. Then you have directly a book object. You can call the cite method directly on that book object. And so then you shouldn't, then this problem wouldn't arise. But the way we are thinking about the design right now, we are going to call it from here. And that has an I document in there. Does that make sense? So we are kind of waving our hands and not actually writing code. But if you were following the previous lectures, how we thought about each one of these, we kind of followed the design recipe, and the helpers came about as we were thinking the original method. So we kind of did this top down. We started with the method that we were going to design, which in this case is that bidbooks. And then when we were implementing that method, we wished for certain methods to exist. And then when we wish them, we know directly where do we wish we had them. And that will lead us to the helper methods. Today, we are kind of doing this backwards because we are not writing the code. Kind of looking at, okay, that is a piece that we're going to need, so let's write that piece first and then figure out how to use it. Does that make sense? All right. So given this method, now we have to think about how to write the bidbooks method. So since I see from the class participation today that most of you did not look at this problem, I would like you to now think about it, and we'll come back to it tomorrow. Okay? Because that's a method that's interesting to design. I would like each and every one of you to think about it. Okay? In about 2 or maybe 3 weeks, you have the first exam coming. Do you know what the most popular question on Piazza is when the exam comes closer? Can anybody guess, since many of you are going to likely ask that question? What is a good way to study for the exam? Well, start here. Okay? This is the reason those practice problems exist. So give yourself some practice, because you're going to be doing this a lot. Not just the first exam or the second exam of Fundies 2. You're going to be solving problems like these pretty much in every course. Okay? So give yourself the practice to think about it. Okay? More than half of the times you'll find yourself eventually stumbling, or what you think is stumbling upon the correct answer. That's okay. No, there's almost never a linear path to the perfect solution. Kind of try things, see how they work. If they don't work, why don't they work? How will they have? Sean, yes, will there be a curve? That is probably the most popular question right after the exam. Will there be a curve on this exam? So that would be, I think, the second popular question on Piazza. I can answer that one right now. No. Okay. We said before we're not going to curve anything in this course. We stand by that statement. All right. So from that, so please think about this problem. We will come back to it tomorrow. Okay. So let me unshare and reshare so that you can see what I'm writing now. All right. So for today's materials, for today's lecture, we're going to go back to the shape classes. And I've reproduced the design and the code that we developed in class about a week ago for this. So we had an I-shape class, and we had 4 methods for it. The area of a shape, the distance of the shape to the origin, grow this shape by an integer factor, and then is the given point inside the shape. Okay? So just to recap what we did, we wrote those 4 methods, then we wrote 2 classes that implement that I shape. So here you see the design in class diagram form, and if you just span, you will also, it's not the complete code, you can refer to that self-deferential, the methods and union types, that page, in order to see the details. But this is what our code looked like. class circle implements I shape, class square implements I shape. Okay, and then for each one we wrote the 4 methods, and they were different. For example, the way you compute the area of a circle is different from the way you compute the area of a square, and so on. Okay. So we wrote those 4 methods. When we were writing the this to origin method, we found out that our implementations for the circle and square class were very, very similar. Both of them had the square root of the square of the x coordinate of the point plus the square of the y coordinate of the point. I hope everybody remembers that, right? And so that led us to observing, hey, is there a way we can not repeat ourselves? And so that's what led to this point 2D class that we wrote. We wrote a separate point 2D class. That had an x and a y. And then if you remember, we wrote a method called distance to another point 2D. That returned us a double. Okay, and then both of these ended up using the point 2D. So that's what our class diagram ended up looking like. And they use the point 2D. If you look at the fields, we call this one the center and that one the lower left, but both of them are of point 2D. And the benefit of doing this was that now the this to origin methods could simply delegate to the distance method in the point 2D class. Okay? And that is how we arrived to this design. Any questions about this design before we move on? This was where we were at the end of that lecture. Now, let's try to add to this design somewhat. So let's say I have to add a third kind of shape now, a rectangle. Okay? A rectangle is also going to be represented using the lower left corner, and then it is going to have a width and a height. Okay? And so how do we actually incorporate that into this design? Let me make space for it. Oops. So I can create a rectangle class that implements my I shape. It is going to have a lower left. That is a point 2D. It is going to have a width. That is an integer. A height. That is an integer. And then the 4 methods as they were over here. So we got our area. That is a double. This to origin. That is a double. Then we have our grow. That is going to produce a rectangle. And then we have an inside. That is an int x. int y, that will produce a boolean. Okay, and so because this is an I shape, we make that implement I shape as well. Okay, and so this also uses the point 2D. So that's the class diagram we have. Okay, code-wise, it's going to be very similar. So I'm just once again going to copy the code. And so instead of square, this will become rectangle. Okay, and so here's what the code will look like. All right. Now, when we actually implement this, let's see. So area of a rectangle is width times height. So we'll do this dot width times this dot height. This to origin. So this to origin is going to say return math dot square root of this dot. No, so this to origin is going to just say return this dot lower left dot distance, and we pass it the origin, new point 2D 0, 0. Okay. The grow is going to grow the width and the height by a certain number and then return a rectangle with those dimensions. And the inside, once again, is going to be, hey, is this x coordinate between lower left x and lower left x plus width? And is this y coordinate between lower left y and lower left y plus height? Okay? So I hope what you're noticing is that quite a few of these methods are very similar to methods that we have written before. Let's compare it to the square class. The dis to origin of the square said this dot lower left dot distance, and we passed it the origin. So actually, exactly the same as what we just wrote for the rectangle. Okay? The inside, also roughly the same kind of logic. So we are repeating ourselves here. And perhaps we realize this when we are writing code, but when you think about it, this is not surprising at all. Why? Because a rectangle and a square are actually very similar to each other. In fact, a square is nothing but a rectangle with the same number for its width and height. So because the two classes represent shapes that are very similar, that similarity manifests itself in the code. That is not surprising at all. But the question is there a way to capture this similarity so that we don't have to repeat writing the same code over and over again? Are there other instances of this happening in the design? So let's look at our class diagram now. Right here. Each one of them, circle, square, and rectangle, seem to have a field of type point to be. Now, sure, we have named them different because the reference point has is called by a different name depending on what shape it is. For a circle, it's the center. For a rectangle and a square, it happens to be the lower left corner. Okay? So yes, there are some differences in naming, but basically all of them share that. And once again, that shows itself in that method distance in the point2D class that all of them seem to delegate to. So once again, there is some similarity. And so is there a way we can write the code that is repeating itself one time instead of having to repeat itself several times across the classes? And yes, there is. What we need in here is a place somewhere in our code where we can put everything that is in common. And then somehow have that piece of code be shared by all the classes that do have those things in common. Okay? So here's what we're going to do. I'm going to move this. I'm going to first kind of illustrate the example at the class diagram level, and then we'll modify the code. And so here, I'm going to create a new class. I'll call it an A shape. The A standing for abstract shape. Okay. Why this name will become apparent soon. So A shape right here. So A shape is going to implement the I shape interface. Okay. I want all three classes to share whatever I put in the A shape class. And so we say a circle is an A shape. A rectangle is an A shape. A square is an A shape. Similar to how we said a circle is an I shape. Okay, so it's the same is or relationship that we have seen before, but this time we are trying to relate two classes with an is or relationship. Okay, before when we said circle is an I shape, the circle was a class, but the I shape was an interface. Okay, so it's the same is or relationship. We mean to say the same thing, except we are now using it to relate two classes together. All right. So in class diagram notation, the way you say that, you use the same arrowhead, but now instead of a dotted line, you use a solid line. Okay. So that is what our design ends up being. We've essentially added a class between that interface and all the classes that were implementing it. We make this new class, implement iShape, and then we relate those three classes with an is/or relationship. Okay? We call that an abstract shape. Now, in code, what does this look like? So here, I'm once again going to move things over. Okay, that should be enough. All right, so here we have our circle. And so now we'll write class A shape implements I shape. Okay. So this part is as it was before, but now the circle, instead of implementing I shape, I want it to relate to that A shape class. Actually, I'll keep it there so that we can see the before and after. Instead of that, we will say extends A shape. Okay, so this extends keyword is an is/or relationship between classes. Okay. Similarly, for the square, we say extends A shape. And for the rectangle also, we say extends A shape. Okay. So that is how we capture this triangle arrowhead with solid lines in code. Instead of saying a class implements an interface, we say a class extends another class. Okay? Now, it's not entirely how it is, but a simple way to imagine this would be if my circle if my A shape is like a box. Okay, you can think of it as a box that has the fields, and methods in it. Okay, then the circle is going to be this box inside of which there is the A shape. So taking the word extends in its literal sense, it means a circle is an A shape plus something. Okay, and so you can kind of remember that picture, although accurately it's not quite as simple as that, but it's a good way to kind of understand what we just did here. Harris, yes, an A shape is not an interface. An A shape is a class, as we can see here. It's a class A shape. It's the one that implements I shape. All right, yes?
What would be an example of a class as part of the interface, but not part of the abstract class?
What would be an example of a class that is an I shape but not an A shape?
Yeah.
Let's answer that question at the end. That's a good question. Right? I want to defer answering that question because we haven't developed the A shape yet. We don't yet know what this thing actually is. As of now, it's just an empty thing. Right? Other questions? Okay. So if we look at the class diagram, what we have just given ourselves is that we have given ourselves a class that all these three have in common. So in other words, that class you can think of as the place where if we write anything, all the three classes will get it. And so it's a place to park everything that is common between all our classes. Think of it that way. All right? Now, what could be common between these three classes? There would be some fields, possibly. It's a class, so it can have fields, and it can also have methods. Okay? Lucas, how would dynamic dispatch work in this case? Does it propagate the decision down the A-shaped class? That's a good question. So remember how dynamic dispatch works. When the program is running, and when it comes to that line, it now says, okay, what kind of an object do I have? And so the kind of object you might have at that point would still be either a circle or a square or a rectangle. And so dynamic dispatch is going to go to the correct one of those three. That never changes. Okay? When it comes down to it, when the time comes for Java to ask that question, what kind of an object are you? The answer to that question doesn't change just because we added an A shape. It is still going to be one of the three kinds of shapes that you created. And so it will continue going there. Okay? All right, so let's first start talking about fields. Can this A-shaped class capture fields that happen to be common to everything? Okay? Remember that anything that is in common between the three classes, we can put up in the A shape. And because each one of those three extended, they would get it. Okay? The counterpart of that is that the converse of that is that if you put something in A shape, all of the classes that extend A shape will now get it. Okay? You no longer have a choice saying, well, I said extends A shape, but I don't want that field in there. Nope, you don't have a choice anymore. Okay? So if you put something in that A shape, all of the classes that are extending it are going to get it. So that's why we have to exercise some caution before we start putting things up there. Okay? Now, let's look at the three classes that we have. We have circle, square, and rectangle, and they're fields. So the radius, side, and width, height are obviously different for all three. So those would not go up. But each of them have a reference position. We call it by a different name, but it's a reference position. Okay? And so we could capture the fact that all of these shapes have a reference position. And that allows us to kind of take those fields out of each one of them and instead put them in the A-shaped class. This is called lifting the fields. You can think of it as literally holding those fields and lifting them up the class diagram and putting them up here. Okay? What does that actually look like? Well, in class diagram, it literally looks like you need to think of a name for this field that would capture what it represents. So I'm going to cancel it from here. And then put it here. So I'll call it ref point of type point2d. Okay, so I will cancel all of them here and I'll put it over there. Okay, because I have lifted the fields, now it is the A shape that has a reference point. So I must now remove these arrows and instead connect it that way. So that's what my class diagram now looks like. Okay? What does that look like in code? Here my A shape is going to now have a point2d ref point. Okay? There are no other fields that I could lift up, so that's the only one. So I still must write a constructor. So I had an int x and an int y in the constructor, so I'm going to continue doing that. And I'm going to say this dot ref point is new point2d x comma y. So I put the field right there. Okay? Now the constructor here that was there before, int x, int y, and int radius. Okay? Initially I had this dot center equals new point2d x comma y, and I had the other this dot radius equals radius. Okay, but now I don't have a this dot center anymore, and so I will remove this. Now I could say instead of this dot center, I could say this dot ref point, because we know that it gets it from the abstract class. Okay, but I already have written a constructor in the abstract shape. And so somehow I want to call that constructor from here. Okay? And so this gives rise to another keyword in Java. The circle object can refer to itself by saying this. This means this class. Okay? If it wants to refer to something that is in A shape, then it says super. Okay? This is me. Super is the thing I extend. All right? And so to call the constructor, I just say here super. Instead of using the name of the class itself, I say the keyword super. Okay? And then once I say super, you pass to it the parameters that that constructor is going to expect. And so it's simply super xy. Okay? So looking at our analogy, our picture there, this refers to that outer orange box, and super refers to that inner shaded box. All right? So this concept that we have where one class extends another class, the name for this relationship is called inheritance. Okay? And it works like real-world inheritance. We inherit the traits of our parents. In this case, it's a single relationship. And so this class inherits all the traits of whatever class it extends. And what does that mean? It means whatever fields that class had, I have those fields. Okay? So the circle does have a reference point. The square similarly has a reference point. The rectangle has a reference point. Does that make sense? And so every time I want to say something, hey, call it from the thing I extend, I call that my parent. So an inheritance relationship is often also a parent-child relationship, okay? Or a superclass subclass representation relationship. These are all analogous. They mean the same thing. When you have circle extends A shape. Remember the class diagram to know what is parent and what is child. Okay, in a family tree, you would draw the parents above and then children below. Okay? So the parent-child relationship. The parent here is the A shape, the child here is circle. And so if a class wants to refer to itself, its own object, then it says this. If the class wants to refer to its parent, then it says super. Okay? And so parent's constructor just becomes super. Does that make sense? All right. So that's about fields. Now let's talk methods. Are there any methods in these classes that were identical? As you think of that, I'm going to answer Luke's question first. Which constructor should we call when we are making a circle I-shape? A-shape constructor or circle constructor? When you're writing an example, when you're creating a circle object, you call the circle constructor. Okay? And so we won't have time to talk about it, but calling the A-shape constructor isn't even an option. Java is not going to allow you to do it right now, and we see kind of why. If you look at it, the code says class A-shape implements I-shape, right? That means what does Java now expect A-shape to have? It expects A-shape to have an implementation of the area method, the dist to origin method, the grow method, and the inside method. That's what implements means. Does the A-shape class actually have all those methods right now? No, it doesn't. So it's like an incomplete class. There are parts of it that are not defined. Okay? And so the simple rule is, if your class is not fully defined, you cannot create an object of that class. In fact, that is exactly why this class is referred to as an abstract class. Okay? Much like art. There's concrete art, and then there's abstract art. Okay? It's incomplete. It's vague. It's not fully specified. And so you cannot instantiate classes that are half complete. And that's why any attempt to say new A-shape is going to give you an error at this point, because there are parts of A-shape that need to be defined that aren't. Okay? Caitlin asks, does this mean that we will have a field of a field problem with all the methods that use a point 2D, since the shape classes won't have direct access to it? That's a good question, but an inheritance means I have those classes. Okay? I own it. For example, I say, I have brown skin. I have brown skin. I got it from my parents, but the skin is still mine. Right? And so the same way, it may be inheriting that ref point from its parent, but it's still one of its fields. And so trying to access ref point is not a field of field problem. You can directly access it. You directly access. It's just a different place that we have put it in. But this is different from saying the x coordinate. Well, the x coordinate is not part of the shape. The x coordinate is part of the point 2D, and the shape keeps track of the point 2D. So then that would be a field of a field. But this is not a field of a field. This is the field directly. Okay? All right, so we have the ref point. Now we have to think about which methods are identical. And we already saw one that is identical, that dist to origin. All of them use the reference point. Okay, and so next time we will find out, we will determine how similar to we lifted the fields up, we will lift the methods up, and then see where that leads us. Okay, so that's all for today. I will see you on Wednesday.